Hi everyone, welcome to the ChipSkills. Let's start with a small question. Suppose I give you a smartphone and ask you a simple question. How does this small device store thousands of photos, videos, and games and performs billions of calculations per second? Let's think the answer. The answer isn't magic, it is digital electronics. Digital electronics is the language that every computer, processor, and semiconductor chip understands. In this series, we will learn the language step by step from the fundamentals to the concepts used in the real chip design. Let's start the course. Can you guess why your voice is analog but your WhatsApp message is digital? By end of this video, you clearly understand the difference between analog and digital systems and why both are important in modern electronics. Let's see. Electronic circuit and system is classified into two types. One is analog, one is digital. Let's see one by one. Let's take analog analogy. Suppose if you are driving a car, you placed your leg on an accelerator pedal. Suppose if you apply a little pressure, the car will move with a little speed. Suppose if you apply a full pressure, the car will be moving with a more speed. As seen in the car accelerator analogy, based on the application of the pressure on the accelerator, the speed is going to vary. Suppose if you press a little, the speed is going to be 20 km per hour. Suppose if you press fully, the speed is going to be 100 km per hour. So the output can take any values within this. This is a system is called analog system. Let's see the what is analog system. Analog system processes the information using continuously varying signals. Here the keyword is continuous. Let's see example. A voltage varies from 0 to 10 volts. So the voltage can take any values between 0 and 10. So let's take an example 1.23 volts, 3.7 volts or 5.001 volts. These are infinite many possible values. This sine waveform is example for continuous varying signal. So the values can take any value between minus 5 volts to plus 5 volts. Let's see the examples of analog system. First one, audio amplifier. Audio amplifier functionality used to increase the strength of a weak signal. Second one, radio receiver. The receiver amplifies and filters the signals. Signal generators. It produces sine wave, square wave, etc. Fourth one, analog speedometer. In old vehicles, you used to see a needle that measures the speed of a vehicle. Let's take digital system analogy. Example light switch. The switch has only two options, either 0 or 1, means off or on. The switch cannot be 30% on or 75% off. It can take only two stages, either 0 or 1. So this is a very good example of digital systems. Digital systems. Let's see the definition. Digital systems represent information using the discrete voltage values. Here discrete means fixed. So it can be either logic 0 or logic 1. This is the example of digital system. It can consider either 0 or 5. It cannot consider any values between them. Suppose if a signal encounters 4.8, so it will be moved into the 5 volt. Characteristics of digital design. Let's see one by one. Easy to design. Digital engineers only work with either 0 or 1. There doesn't occur any other values. So design becomes simpler. Information storage. RAM, SSD, hard disk. This stores enormous amount of data. Third one, noise immunity. This is one of the biggest advantage. Suppose if you are sending a signal 0, due to some noise it corrupted to zero point 0.1, but it will take still it as a 0. Next example, fabrication using ICs, where billions of transistors can be fabricated on a single chip. Next one, reliability. Digital systems are more reliable. Limitations of digital system. One of the major drawback of digital system is real world is analog. Example, sound, temperature, pressure. Let's take one more real time example. Suppose if someone asks you a time, you will mention it as a 7 o'clock. But computer can understand it as a 111 in the binary language. This is one of the major drawback. And a digital processor cannot directly process the analog quantities. They need ADC or DAC to convert from analog to digital or digital to analog. Hybrid systems. Hybrid system is an electronical system that combines analog circuits and digital circuits to perform a complete function. Example, take a smartphone. Your voice, which is a sound wave, When it passes through the microphone, it will be converted into the electrical signal like 0.2 volts, 0.4 volts, etc. After that, it will be passing into the ADC, analog to digital converter. Now, the analog information 0.2, 0.4 will be converted into the binary forms. After that, it will be processing into the digital processor. Digital processor functionality is like encryption, noise cancellation, and it has lot of functionalities. After that, it will be passed into the DAC. Why DAC, right? So speaker is an analog device. So we need to convert the binary information to the analog information. By using digital to analog converter, we will convert this information and passes through the speaker. Let's see questions for this session. Please write the answers in the chat box. Thanks for watching this video.